Hello and welcome. My name is Toni Doolen, and today I'm joined with three incredible women who are recipients of the 2024 Society of Women Engineers Distinguished Engineering Educator Award, Gretchen Hein, Katy, Diane Peters. This is one of SWE's Apex Awards, the highest level of awards that SWE offers, which honors individuals with 20 or more years of professional experience. I'm currently serving in my 13th year as Dean of the Oregon State Honors College and Professor of Engineering since 2001. I've been involved in SWE at the local, regional, and national level for over 35 years. I appreciate the role that the Society has taken in making visible and celebrating the significant contributions of my fellow engineering educators. Now let me introduce our panelists. Dr. Katy is a professor in the Department of Chemical and Materials Engineering at San Jose State University. Dr. Diane Peters is a tenured associate professor of mechanical engineering at Kettering University. And Dr. Gretchen Hein has served as a faculty member at Michigan Technological University for over 25 years. In their own and unique ways, each of these women has moved the field of engineering education forward, from implementing fresh and engaging ways of teaching, to setting standards of excellence in the field, to guiding and supporting students throughout their educational journeys. Congratulations to each of you on being named as SWE's 2024 Distinguished Engineering Educators. Now let's learn a bit more about you and your work. So to start, I'd like to understand why you chose to go into engineering and how you ended up as an engineering educator. Katy, could you start us off?
Hi, thank you for having me today. So to answer this question, I need to go back to high school. So neither of my parents went to college, so I didn't really know what I wanted to go into when I was applying to college. And so my parents told me, "Why don't you call up your professor uncle?" And in Cincinnati. So I called him up and he asked me a few simple questions. Do you like math? It's like, yes. Do you like chemistry? Yes. Do you like physics? Yes. Well, why don't you go into engineering? And why don't you go into chemical engineering? And that's where I ended up in chemical engineering. And the reason I got into engineering education was so during graduate school, we are all required to TA, a couple of quarters before we graduate with our PhDs. And I really enjoyed that experience. I enjoyed interacting with the students. And to be honest, when I had to teach for the first time was when I really felt like I have a firm grasp of the topic. And I knew, I think right then, I just love that interaction with students. I love, standing up there explaining to students and kind of seeing that light bulb that comes on when they get it, and, just trying to find different ways to explain things. And that's how I got into engineering education.
Wow. Mine's a little different. I wasn't going to be an engineer in high school, and I was going to be an architect. And my dad started talking to me, and he was an engineer, and he said, well, you might want to look at mechanical engineering. And I did. And he said that because I was very good at taking just about everything in our house apart and putting it back together. Whether it was broken or not, I would take it apart. So I did get my bachelor's in mechanical engineering. And then I said, well, I'm done with school. I'm never going back to school again. And so I worked. I went out in industry and I worked. And then I got on a job where I was working with faculty at Purdue, and they said, you should go to grad school. And I'm like, I don't think so. And so that's kind of with my thing. It's like, nope, not going to grad school. And so I got to do a field trip at Purdue one day. And then all of a sudden I'm going to grad school at Purdue. Finished my master's. And once again, I said, I'm not going to stay in school. And then Michigan Tech offered me a fellowship, but I was like, okay, I'll go get my doctorate. And so mine just ended up being like a bunch of saying okays, not intent, but it was like, oh, this looks like fun. And then why did I take up teaching? when I finished my doctorate, I knew I didn't want to do research, but I still wanted to use my education. And by then I really liked school, and I figured, okay, if I kept saying okay to school, then I really belonged in a university. And so I became a teaching professor, and that's been really great. And I also realized about midway through that I'm very good at talking to people and students. But then when I was looking out, I'm like, Katy, I wasn't seeing the light bulb. And so about midway through my career, I said, okay, I'm going to shift. I'm going to go from teaching to learning. And once I did that and started focusing on learning, then I started having a great time because the light bulbs were going on and my class became really interactive and we were all having fun learning thermo, which is a really weird class to have fun doing. And so that was my path to teaching.
Mine was a little bit similar to Gretchen's, although I had some differences. I think I was an engineer before I knew it. There's stories in the family of me building things with Legos and all sorts of building sets. My older sister has a story she told me once that when she was in elementary school and I wasn't yet, that I took a piece of graph paper from my mom's desk in order to draw out what I was going to build with her Legos while she was at school. My mother used to have to tell me, please move the skyscrapers off of the table with your beams and girders set. It's time for dinner. But like Gretchen, I thought I was going to be an architect when I was in high school. And it was my father, who is a chemist, and my mom is a mathematician, who encouraged me into STEM fields. And my dad knew a lot of engineers. And he said, Diane, you might like the stuff that they do. Think about that. So I said, okay, I'll think about it. I took an intro to engineering class, and well, that's it. That's what I'm doing. But like Gretchen, I didn't go straight on to grad school at all right away. I told people, no, I'm done with school forever. And then I went into industry and I was doing machine design, and I discovered I didn't know everything yet. What a shock. So I pursued a master's degree in night school because I wanted to learn things that would make me better at my job, that I could do all sorts of cool things with. So I got my master's degree and I said, I'm done with school forever. This time I mean it. Until I didn't. And the thing that got me into engineering education and that got me to go back for my Ph.D. was an opportunity to teach at night at a community college. I was living and working in the greater Chicago area, and Oakton Community College had somebody teaching there who I knew. And at the last minute, he couldn't teach a class that he was going to teach. And it was on a CAD program that I used at work all the time. And he suggested, hey, Diane, why don't you do this? Let me talk to the department head. And they hired me with a few days' notice to teach this class. And we all agreed that, I'll do it for one term and we'll see where we stand. And I really liked it. So I did that for a few years. And then I decided I wanted a career change. So I quit my job and sold my house in Illinois and moved to Ann Arbor, Michigan, and bought a house there and enrolled at the University of Michigan for just a minor life change in midlife.
Those are wonderful stories. Thank you so much. So in the time that you all have been in engineering and engineering education, how has the landscape changed since you were a student? Do you think that the skills and competencies to be a successful engineering student have changed at all? Gretchen, why don't you kick us off?
Wow. Okay. This one, I actually read the questions before, and this one for me is the most challenging. I think in the group, I might be the oldest. So I got my bachelor's in the 1980s. And I actually went to Kettering, which is where Diane teaches. And when I was there in the mechanical engineering class, there were 3 women. That was it. We were it. And that, I think, is the biggest change. Now, how is the competencies? I think they're pretty similar. I think they've been tweaked. I think the use of technology in the classroom and in industry is very different. I can remember when I was first in school, most of my labs were hands-on. They did not involve a computer at all. And including, like, we had descriptive geometry where we're at a drafting board and plotting out points on planes. And I don't think students even do that anymore unless it's using like a 3D modeling package. I learned Fortran. That's not even taught anymore. But I don't think the competencies, if I look at a mechanical engineering program, you still have to do statics, dynamics, you still have to have physics, you still have to have chemistry. I think the courses haven't changed. I think the content has because of how technology has influenced the classroom. I also think the students have changed over 30 years. They seem to be like, the prof is less of a sage on the stage, and it's a more cooperative learning environment, which I think is a huge, 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 fantastic, positive change in engineering education. And so now I want to hear what Diane and Katy have to say.
Yeah, I think you're right when you say you're the most experienced here. We'll use that term. Things have changed a lot. Like you, I learned on a drawing board. I didn't probably use it for as long as you did, but I do still remember how to use that T-square and triangles. So I think that you're right that a lot of the tools have changed. We do have a lot of computer tools that we didn't used to have. But one of the points that I always make to students is that garbage in, nicely graphed, pretty formatted garbage out. You have to understand the concepts. So maybe you're not doing all of the follow the steps to draw the root locus by hand and calculate this and the whole process. But you have to be able to tell when the software is giving you crap. You have to have enough of an understanding that you can look at it and say, you know, I must have entered something wrong, or there's a glitch or something, because this just doesn't make sense. So I think that the fundamental basics of the field, the concepts and what kinds of things students need to learn at that theoretical level are the same. The tools are different. Their capabilities are far better, which is good because if we use them right, we can then spend less time on the tedium of going through many of these processes and more time on, okay, what do you do with it and what does it mean? I think that, like Gretchen, teaching methods have changed over that time. And I think that students have changed both in their background and their passions and why they get into engineering. And we've also had a change in the diversity within engineering. Like Gretchen, there were very few other young women in many of my classes. Sometimes I was the only one, and now we have more. There's many more women who perhaps would make good engineers who don't yet know it, but we're certainly better than we were. And it's been great to see those changes over the years. Katy, what do you think?
Yeah, I completely agree with both you and Gretchen. I mean, so first off, yeah, the demographics has really changed. Same with me. When I was an undergrad, I was one of, a handful of females. But now in my classrooms, I'm seeing maybe, 30%, female engineering students, which is great. And also in terms of, I completely agree with the technology, right? Like there's so much more reliance on technology as well from the students' point of view that I find myself constantly to have to like remind them exactly what you do, right? With, Diane was like, hey, we need to understand the fundamentals before you could run these simulators. Because you need to understand, right, what comes out actually, whether it makes sense or not. And I also find that students seem to have shorter attention span as well. So, when I was an undergrad, I could sit there for, an hour and a half, however long the lecture is, just copying notes, right? Whatever equations that the professor's writing on the blackboard. But now, like, students don't have that attention span to do that. And so, I've definitely had to, through the years, I've had to adapt my teaching styles to match their learning styles, which I think it's better, right? We want to spend less time on, deriving these equations, like what Diane was saying, like the tedium of things, but focus more on the application, right? What can you use these equations for?
Well, that's a wonderful segue into my next prompt. So from your nomination packets, we know that all of you use different hands-on or what we call experiential learning methods as part of the pedagogical approach to how you engage with teaching and connecting your students. You also oftentimes are connecting students to the practice of engineering, not just the theory of engineering. So it'd be really interesting to hear why you think that these approaches are really important in engineering education today. And feel free to reflect also, as Katy did, on how you've had to adjust your teaching over time. And maybe we'll start with Diane.
Sure. One of the advantages I have with having an industry background is credibility with our students. For those who don't know, Kettering University is a co-op university. Our students spend half their time in the classroom and half their time working at co-op. So they have lots of hands-on experiences. And the fact that I do too gives me credibility so that when I say you're going to need to know this, they know that I've been there. I've been where they are. And one of the things that I find really useful is to tie things in to their work experience, to ask them at the beginning of the term, what is it that you do in your co-op? And then sometimes it's really unrelated to the class I'm teaching because it's enormously diverse, as is every field of engineering. But other times somebody will say, well, yeah, I was doing this NVH project and we were dealing with natural frequency of the system. And I will look at them and say, okay, we've got a lecture a couple weeks into this class that you are going to just absolutely rock because you've done it. So drawing on that is helpful. It really helps them to develop a sense for things, for what makes sense and what doesn't. So I've told them a story about a class I took once. We had this very long take-home test. It was a class in polymers. So it was a materials class, not mechanical engineering. And I don't remember the exact calculation that I was doing, but I do remember that it was very easy to make a dumb mistake with it. Maybe it was parentheses, maybe units, whatever. But it was also easy to tell you made a mistake because you would find that a high temperature process was taking place at minus 40 Kelvin. I don't think so. So that is the kind of sense for reality that you want students to develop. And part of it can come through just familiarity. Part of it comes with things being hands-on. You calculate something and you say, okay, does this number make sense? So for example, in my current class, I have a project where they're taking data off of a model of a quarter car suspension. And that's the suspension of the vehicle if you basically chopped it up into 4 unicycles and said, what would I feel if I was sitting on this little unicycle going over the road? And one of the things that I talk about is the assumptions that go into it. Like we assume a tire is a stiff spring. No, it's actually not. That's a vast oversimplification. But I also talk about the scale of things. Okay, so if you were to calculate on this little tabletop thing that's about maybe a couple feet high, if you were to calculate that the suspension stroke is going to be 1.25 meters, they all start laughing because they look at it and say, no, it can't possibly be. That thing physically can't do that. So I think that it helps them to get a really good grasp of things, and it makes it feel more real, and it gives them a greater degree of confidence that they really can trust what they're learning. And it's not just looking at equations. I mean, Katy mentioned the equations on the blackboard. Sometimes it seems almost like if you don't have anything hands-on, look at the magic show on the whiteboard. Look at all these equations. What do they mean? Good question. So I think that that's really, really important.
Yeah, and I completely agree. So in terms of kind of the experiential opportunities that I focus on a lot, outside the classroom, especially through research. I try to engage as many students as I can in research because that's where the application comes in. And with most research, it's very interdisciplinary as well. And, especially when we collaborate with different groups, then they have to go outside their comfort zone and learn like I'm in chemical engineering, but, I collaborate with people in materials. So they have to learn, what do these materials characterization mean? What do the data mean? And also, one of the main, I think one of the most important skills that we teach engineering students is problem solving. And with research, there's constant problem solving because vast majority of the time, their experiments will fail the first time. And, I feel like it's through that that kind of failures that they really learn and grow. And that's, that's kind of been my philosophy, is to kind of get students as much hands-on experience as possible. It's more difficult to do that in a classroom. We have project-based learning, but, most of that is, especially in chemical engineering, it's just simulation or things on, paper. But I think kind of that research experience is really important. And that's what I always advise, undergraduate students to gain that experience if they can.
So my philosophy for being in the classroom was I want it to be fun for me, and it won't be fun for me if it's not fun for my students. And so I taught the major class I taught was thermodynamics, fluid mechanics for non-mechanical engineering students. So they have no interest whatsoever in that class. And so my goal was always to figure out a way that they get psyched or have fun in class. So we would do problem solving days. So every couple weeks it was strictly, I pull out a problem, they work on it, and I'm running around the classroom and they're yelling across the classroom. And it's they were always really dynamic and fun days. The highlight for all of my students and me was this thing called Duck Day. And they all knew it was going to happen. And Diane's heard of it. So it was when we were doing heat exchangers, which, okay, if you don't know anything about them, they are not very interesting. All right. So other people disagree, but heat exchangers are not that much fun. And so I was trying to figure out, how do I make this more fun? And then one of our biomed faculty said, well, the arteries and veins are just countercurrent heat exchangers and duck legs. And I was like, whoa, that's my new example. And so we would use research articles where I'd make the students dig out the values we needed for the analysis. And they would do this in class. And I would bring a duck to class because I live on a farm. And so I have ducks. So they all got to meet the duck. Well, usually it was plural ducks. And then we would sit down and do this example. And the really cool thing is they learned about heat exchangers. And for me, where the proof was in the pudding is every exam would have a heat exchanger problem on it. And before that, they couldn't do them very well. After the ducks started coming to class, all of a sudden their ability, whether it was a condensing unit on a power plant or a heat exchanger in a manufacturing plant, they could do them. Well, more reliably do them. And they would get the gist of the problem a lot better. So that's what I like to do. I like to bring in kind of interesting, creative examples to a class that's not typically a really dynamic class.
Wonderful. Well, that's a great way to wrap up that question. So we're going to switch gears a little bit. One of the things that both students and families often want to know now when they make the investment in going to college is, what is the return on investment for a college education today? So if you've had this opportunity to explain the ROI to students and families who are considering engineering in particular as an area of study, how do you make that case to them? Katy, do you want to get us started?
Yeah, so I haven't had the opportunity to explain this to a parent yet. But if a student comes and asks, what's the value of an engineering degree? I think I would point them to the job boards and be like, look at all the jobs that you would be interested in having, and look at the minimum requirements. And just, in education, whether it be in engineering or, just a college education, teaches you so much more than just, your specific field. Kind of, it teaches you teamwork, right? And that's very important in almost all industries. It teaches you how to think broadly because of all the breadth requirements that each student have to take. So it allows you to think outside the box, and also the networking opportunity, right? Like your classmates might be the ones to help you find your first job or a future job. So that's how I would justify that. So what do you think, Gretchen?
All right. So I I'm a mom. I have 3 kids. So I kind of did this journey with my 3 kids. And my whole thing is, when you finish high school, your goal is to choose a career that you can have the lifestyle you want. And one of the advantages of engineering is it can allow you to have a really not a flexible career necessarily, but a lot of choices in what you want to do in your life. That's the thing that I would focus on when I would talk with prospective students and their parents, is not necessarily, okay, the great salaries. And engineering does have a good salary, but it does allow you to have a good lifestyle. And it does allow you to have choices in where you go and what you do. I don't know of any engineering discipline where you're stuck being a double E, or you're stuck being a mechanical, or you're stuck being a chemical engineer. You can always pivot towards something that you want to do. And I think Katy and Diane probably do this too. One of the best ways to discuss career opportunities in engineering with a parent or a student is to talk about your students and where they are now. And then if they really have questions, you refer them to one of your alums. And that's my most successful reference, is not necessarily me talking about what it means to be an engineer, but say, oh, you're a civil, well, you go and talk to so-and-so because she's out there working for this consulting firm. Or more recently, I had a student who wanted to get into air quality, and she was a chemical engineer, and they were more focused on water in her undergrad. And so I got her in touch with somebody who was working in air quality with a chem eng degree. So that's the secret. It's not selling the money, it's selling the career and the opportunities and the lifestyle that's available. At least that's my viewpoint. Okay, Diane, your turn.
Well, that's actually a great question, because that's something that Kettering actually boasts of. We're rated really well in terms of ROI. If you look at the salaries that our grads make compared to what it costs to get a degree. So it's something that we rank very highly on. But I think it does go beyond just the money. Not that money isn't important, because, well, we need it to pay for the various things that we need in life. So it's certainly important, but it is also, what do you get to do? And one of the great things about engineering is that you do have the opportunity to do work that matters. And there's a Dilbert cartoon that I saw years ago. And if you're familiar with Dilbert, it's this nerdy guy who works in a cube farm, and the Prince of Insufficient Light, who is their devil light, I guess you would call it, tells him that he's going to be cursed, and he can choose one of 2 options: a career that is meaningful but low paid, or one that is highly paid but it's utterly useless. And he says, wow, those are both better than my current career. But that's actually not true of engineering. You can make good money, but you can also do things that matter. And what that looks like is going to vary to different people. Like Gretchen, I have alums who work in a lot of amazing jobs. I have tons of alums who have been through my classes who have gone to grad school, and some who've gone on to various industry positions. And the key thing about them is that they're happy with what they're doing, is for the most part. If they're not, they can change. They have the skills. Katy was talking a little bit about the teamwork and all these other skills that students learn in the problem solving, and they can take those to other settings. So if they decide, this was a great run as a mechanical engineer doing automotive design, but I'm really ready for something else, they have what it takes to go and build on that foundation and do something else. So you get a great return on investment financially, which is important if you're considering you're going to have to pay for college, but you also get a great return in the sense of you have a career where you're doing things that are important to you that contribute to society.
That's a great way to sum that up. So this has been a fantastic conversation, but our time together is nearing an end. So to wrap things up, we're going to close with a prompt that we've been asking other Apex awardees. So the prompt is, if you could speak to your 16-year-old self, what advice would you give her about considering a career in engineering? And we're going to kick things off with Gretchen this time.
Wow. Okay. So when I was 16, thinking about college, all I could think about is I'm going to be stuck in a job for 40 years. That was my viewpoint. So if I were looking back at being 16, I would say, stop looking at 40 years. All right. Look at it as an adventure. All right. Where changes and challenges are just jumping points to the next place you're going. And I would pick a goal, like I would find a goal, not always the same goal, you know, they change over time, but where the overall journey is like full of all different kinds of people with different ideas and perspectives, because it's the people that's going to make the journey fun. It's the people that are going to make the journey rewarding. And if you have good people with you, the career comes along. And so does everything else that goes with it. At least that's my viewpoint. I love the people I was with. And that made the journey worth it. Okay, Diane.
Well, if I could go back to my 16-year-old self, I think I would sit her down and I would say, okay, number one, take a couple deep breaths and stop stressing. Because I did stress out over grades more than I needed to and over what my future was going to be. And then I would tell 16-year-old me that you're going to change over the course of your life. And the things that are perfect for you now are not always going to be perfect for you. Not because there's anything wrong with you or them, but because you're going to grow and change, and the world is going to change as well. The world you live in when you are in your 50s is not going to be today's world. And that's not something to be scared of, and that's not something to be intimidated by. It's something that you're going to have to grow and change. And it's okay to change your path. Just like Gretchen, I was not planning to go to grad school at all. That was a change. And I could have said, no, I had decided that this is who I am and what I'm doing, and I'm not deviating. But I did, and I'm glad that I did. So I would tell my 16-year-old self, don't be so certain. Don't be quite so, I know the way it's going to be about your future, because it's okay to not know what's going to happen, and it's okay to just make it up as you go along. How about you, Katy?
Yeah. So I really love what you said about journey, about, enjoying the journey, Gretchen, because that's actually what I would tell my 16-year-old self if I could go back, is that to just enjoy the time that I had, because looking back, I had a lot more free time to enjoy different hobbies than I do now. And also, back to what Diane was saying about not stressing so much. I think I unnecessarily stressed a lot more than I needed to, because I remember crying after every single exam, regardless of whether I aced it or not. And that was a lot of wasted negative emotion that I, didn't need. And be more certain of myself. I think, a lot of young people they're unsure of themselves. They have the potential, but they're not aware of it yet. And I feel like that was me when I was 16 years old. I just like, because neither of my parents had a college degree, I was unsure of myself whether, I could even do anything or achieve anything. But it took mentors to believe in me for me to believe in myself. So that's what I would say to me.
Wonderful. Thank you all so much. So congratulations again to Doctors Katy Cow, Diane Peters, and Gretchen Hein on receiving the 2024 SWE Distinguished Engineering Educator Award. Thank you for sharing your insights with us. And for anyone who is listening who wants to learn more about these women and SWE's full list of Apex Award recipients, you can read their full profiles, which I encourage you to do, in the 2024 conference issue of SWE magazine, which is available online at swe.org/SWE magazine. We also encourage you to visit the WE24 Awards Hall at the WE24awards.swe.org website, where you can leave a message for this year's SWE Award recipients and a note of congratulations. I'm Toni Doolen, and thank you so much for joining us today.